Vectors. A vector has magnitude, which we often represent graphically as the length of an arrow, and a direction, or an angle, which we draw our arrow at a particular angle to represent that. Now, the length of that arrow is denoted by these double bars on each side of your vector. For the most part, vectors are going to be denoted in your notes and in the book as bold-faced lowercase letters. Now, some physical things can be represented as vectors. Some of them are velocity, acceleration, or force. Think of a force. You push against an object. You push with a certain strength, which is your magnitude, and you are pushing in a certain direction against that, and that is your angle. Now, two vectors are considered to be equivalent if they have the same direction and the same magnitude. They don't necessarily have to have the same starting point and ending point. So here we have two vectors. It's starting at 0, 0, going to 4, 5. Here we have a second vector starting at 2, 3, going to the point of 6, 8. We want to show that the u and v are equal. So we got to find their magnitudes, and that's what the double bars mean. And we're going to find our angles by looking at their slopes. So your magnitude is your length, so we're going to just go ahead and use basically the Pythagorean theorem, difference in your x's squared plus difference in your y's squared, because if you would draw this out, you could get a right triangle formed. And well, you'll notice that 16 plus 25 is 41, so we get the square root of 41. Go ahead and take a look at the next one here. Subtract your two x's squared plus subtract your two y's squared. And once again, we get the square root of 41, so they have the same length. We now need to show that they do have the same direction or angle. So for that, we could do the rise over the run, finding their slope, this y minus that y over this x minus that x, and we would get a slope of 5/4. Same idea over here, finding your slope. 8 minus 3 over 6 minus 2. Since both slopes are the same and both magnitudes are the same, we could say the two vectors are equivalent or equal. Now, a vector in standard position, we can write as with these angled brackets here, x, y, meaning it starts at the origin and then goes out from there. Well, our first vector we had up here isn't a vector in standard position. So that vector could be written as 4, 5 in the square brackets. You would not need to have the first part here because you would assume that when you see the angle brackets that you're starting at 0, 0. Then it says to find your magnitude, you square your x plus square your y and take your square root. And that's exactly what we did up here for your magnitude of u. Adding two vectors together. Basically it says you take the first vector and the second vector, you add your two x's, go comma, add your two y's. A scalar multiplier. If you're multiplying a vector by a number, you basically multiply your x by that and your y by that. Well, let's go ahead and find the component form of this vector that starts here and ends up here. There's a couple ways you could look at that. One of the ways you could look at that is you could graph it. You know you're starting out here at 2, -4, going up to 5, 7. You start here and you go up. So that means you're going 3 units to the right, 11 units up. So your component form would be 3, 11. Or you could say if I start at 2 and I'm going to 5, I go 3 units over. If I'm starting at -4 and I go up to 7, I got to go up a total of 11. Then I want you to find your magnitude and direction. Well, once it's in standard form, remember, all we do is you take your x and you square it, plus your y and you square it, inside your square root, so you get the square root of 130, which does not simplify. If it did simplify, you should do that. Now, the next thing you want to do is you want to find the angle. The angle we're referring to here is basically this angle. Well, you know your opposite side of 11, your adjacent side of 3, so you'll go tangent to your angle equals opposite of 11 over 3. You get your theta by itself, you got to get rid of the tangent, and then you type it into your calculator and you get approximately 74.7 degrees. Here we need to take a look at 4u. So basically you take u, bring it down, take 4, so you got to take your 4 times each one of those. So your 4 times your -5, -20. Your 4 times your 2 is your 8. Here you need to take your u and your v and add them together. So here's your u plus your v, so you got to add your two x's together, add your two y's together, and that's what we're doing here. Here we're dealing with 2u minus v. So first of all, you got to figure out 2u. There's 2, there's your u, there's your v. So you take your 2 to each one of the u's, parts, minus your v. So you got a w, you're going to get 10, w, double your 2, and you get 4. Now we're just subtracting, so you got to take your -10 minus your 6. Your 4 minus your -3, and remember when you subtract a negative, it's like adding. Definition of an I and j. Basically, an I is a unit vector going 1 unit to the right and 0 up. J is a unit vector going 0 units to the right and 1 unit up. So if you wanted to express your vector of 3 over and 4 up in terms of i's and j's, you go 3i, because you're going 3 horizontal and I is horizontal, plus 4j, because j is vertical, because you're going 4 up. So now, here we want to find our magnitude and direction. If you wanted, you could go ahead and graph this. It's 2i, so you're going 2 units to the right, minus 1j, so you're going 1 unit down. Your component form is 2 to the right, 1 down, or 2 -1. Your magnitude then is this side squared plus this side squared equals this side squared, so then you got to take your square root, so you get the square root of 5. Then you want to go ahead and find your angle, and once again your angle would be this one right here in your triangle. Once again, you know your opposite and your adjacent, so you'd use tangent. Tangent to your angle equals opposite over adjacent. Solving it for your angle, you get tangent of your inverse being -1/2. You're not supposed to have that memorized, so you type it into your calculator, and you get this for your answer. Well, here we have a piano going up a ramp into a truck. The ramp only holds 450 pounds, but because it's going up on a ramp and an angle, not all the weight of the piano's on the truck. Question is, will the ramp hold it? Well, this is kind of a diagram of what's going on in the context of our problem. Well, if we simplify it down, this is our simplified version. We're, for the most part, trying to figure out this side here, the weight of the piano on the ramp, which is always perpendicular to the ramp. Your weight of the piano, the 500, goes straight down towards the center of the earth, 30-degree difference in the two. So we're looking for the red. That's your adjacent to your angle, so we're going to use cosine of your angle equals your adjacent, which we're looking for, over your hypotenuse. So remember, cosine of 30 is √3 over 2. So you go √3 over 2 equals x over 500, solving it, and you get this. Now, the approximation of that is this here. If your ramp only holds 500, and you're only having 450 is your ramp, and it has 433 pounds from the piano on it, will it work? Yes, it will.